Yesterday we spent a lot of time in class simplifying radicals. Well, today we're going to learn how to write radicals as a fractional exponent and then fractional exponents as radicals. So how do you do this? Well, fractional exponents can be written as a radical where the numerator becomes the exponent and the denominator becomes the index. So let's take a look at our form right here. The numerator, which is the a, becomes my exponent, and the denominator, which is my n, becomes my index. My index telling me what root I'm taking, square, cube root, so forth and so on. When using the calculator, please remember to put parentheses around the fraction anytime you're trying to simplify your answer. That is very, very important. All right, for 14, 15, and 16, they want us to write in radical form and then simplify. So we have to follow the directions. Even though we may be able to do some of it on the calculator, they still want us to write it in radical form first. All right, x to the 1/5 power would be the 5th root of x to the 1st, which is just x. I can't simplify it, so there's my answer. 15, d to the 7/4 power would be the 4th root of d to the 7th power. I can't simplify that anymore, so there's my answer. 27 to the 1/3. Now, I actually could put that in my calculator and get an answer, but they didn't ask me to do that. They wanted me to put it in radical form first. So it's going to be the cube root of 27 to the 1st power, which is 27. So now put in the calculator cube root of 27 using your math button, and you end up with 3. Okay, let's go on. So we went from fractional exponents to radicals. So now we're going to go from radicals to actual fractional exponents. They want us to rewrite it using exponents. Okay, so we have to follow the directions. So the cube root of y to the -5th will be y to the -5/3 power. And that can't be simplified anymore. The square root of x cubed y, square root. So my index outside here is going to be a little 2. So I'm going to put it out there so I don't forget. So the way I'd write this would be x to the 3/2 power times y to the, there's no exponent there. Oh, it's understood to be 1 to the 1/2 power. So do you see how I rewrote that with fractional exponents? All right, 19 is the cube root of a to the 6th, b to the 9th, divided by -64. Well, if you remember in yesterday's lesson, it said that if I am taking the root of a fraction, I can actually give the root to the top and the bottom. So that's what I'm going to do. I'm going to split it. So I'm going to say I have the cube root of a to the 6th, b to the 9th, divided by the cube root of -64. Okay, so I have a to the 6/3 power times b to the 9/3 power over -64 to the 1/3 power. Okay, let's simplify what I can. A to the 6/3 is a to the 2nd power, or a squared. B to the 9/3 is b to the 3rd power, or b cubed, over -64 to the 1/3 power. I could actually put that in my calculator with my parentheses, make sure I enclose this fraction in a set of parentheses, and I would end up with a -4. So here is my final answer. So we learned how to actually rewrite fractional exponents as radicals and radicals as fractional exponents. Have a good evening.